Okay, example 3 for graphing is a rational function. Rational function will be a function of x divided by a function of x. Rational functions tend to have asymptotes, either horizontal, vertical, or both. So that's the first thing I would probably consider for a rational function. Are there any asymptotes? Recalling vertical asymptotes occur when the denominator equals 0. Okay. This time we have a quadratic function in the denominator, x squared minus x minus 2. So either it's factorable or it's not, and my basic technique on factoring is if I can figure out how to factor it right away, I do it, otherwise I go quadratic formula. This one is x minus 2 times x plus 1. So x equals 2 and x equals negative 1 will be vertical asymptotes. Okay. Know that if you get a vertical asymptote, those are going to be critical numbers for both the first and second derivative also. You can go ahead and find them each time if you wish, but they're going to keep on happening as critical numbers. No points occur at those two values though. So if I try to put x equals 2 or x equals negative 1 on my calculator, it will come back as undefined because you can't divide by 0. Okay. The one reason, well, it still comes back undefined officially, but the one thing that might occur that will make these not be vertical asymptotes would be if either one of these numbers also make the top equal to 0 at the same time. So it's just a quick check. If we try that out, if I put 2 in, 16 plus 16 is 32, minus 4 is 28, plus 1 is 29, so not 0. Put negative 1 in. We get 1 minus 2 is negative 2, minus 1 is negative 3, plus 1 is negative 2. So neither one of those make the top equal to 0. If the top also equals 0, you're probably more looking like instead of a vertical asymptote, it's going to be a hole in the graph. And that could occur, we did that back in geometry. So if the bottom equals 0 and the top equals 0, that means some factoring is possible. And the factored function quite often has a hole in it. Because we're not allowed to use those values, but then we can make the discontinuity disappear, in which case we figure out what the answer should have been, creates the hole. As far as the horizontal asymptote is concerned, all we have to do is focus on the top and bottom highest power. Highest power on top is 4, highest power on the bottom is 2. If the highest power on top is more than 1 power bigger than the bottom, there is no horizontal asymptote. I should say there's no asymptote at all. If they're the same, you get the ratio. So like if it was x to the fourth, it would be y equals 1. Just the highest power will reduce it, right? If it's exactly 1 bigger, it's actually got a slant asymptote, you could divide it. I don't remember those happening in this class though. So if it was x cubed over that, do a long division, y equals some linear function is going to be a slant asymptote. But again, I don't remember those happening. So if they do happen, we'll deal with them then. Alright, so vertical asymptotes are there, 2 and negative 1. Immediately, if I get vertical asymptotes, that gives me a little bit of insight into how to pick x. Okay? I'm not going to necessarily find all my critical numbers, but I'm going to pick numbers near 2 and near negative 1 at least, even if my critical numbers don't end up being there. So if I get a critical number, let's say of 5.6, I'm still going to want to pick 2.5, 3, and 4. Numbers near 2, and 1.5, 1, and 0 going back the other way from 2. I'm going to want to pick negative 0.5, 0, and 1 going to the right of negative 1, and negative 1.5, negative 2, negative 3 going to the left of negative 1. So again, just the general picking rules for asymptotes are there. Pick numbers near the asymptotes, and it allows us to get a better view of what the graph's supposed to look like. All right. Once I've established asymptotes, now I want to start doing calculus. That was supposed to be blue regular marker. Let's see. There we go. Put that in the box. It's important, but we'll just kind of put on the back burner now. If I go f prime of x, and again, this is probably scratch work, f prime of x equals low d high is going to be x squared minus x minus 2. D high is 4x cubed plus 6x squared minus 2x. Minus high d low is going to be x to the fourth plus 2x cubed minus x squared plus 1 times 2x minus 1. Over the square of what's below, that's x squared minus x minus 2 the quantity squared. Depending on these size of these polynomial functions in the numerator and denominator, you're going to have to do some distributive property multiplication. One thing I'm going to caution you about is these rational functions always minus a product. Minus a product. Okay. Quite often the product is multiple things times multiple things. Keep the parentheses around until you evaluate all this and then distribute the minus sign through. All right, so it's going to look like this. F prime of x equals, I'm going to use some different colors. Let's go red for this part. All right, so x squared times everything, negative x times everything, negative 2 times everything is going to be that product. So I'm going to get 4x to the 5th plus 6x to the 4th minus 2x cubed when I multiply x squared times everything. Negative x times 4x cubed is negative 4x to the 4th. Negative x times 6x squared is negative 6x cubed. Negative x times negative 2x is positive 2x squared. Negative 2 times 4x cubed is negative 8x cubed. Negative 2 times 6x squared, negative 12x squared. Negative 2 times negative 2x, positive 4x. Minus, and then I'm going to multiply all this stuff in green. Again, I'm going to keep parentheses around this. X, now let's go 2x times everything. So 2x times x to the 4th is 2x to the 5th. 2x times 2x cubed is 2x to the 4th. 2x times negative x squared, negative 2x cubed. 2x times 1 is plus 2x. Negative 1 times x to the 4th is negative x to the 4th. Negative 1 times 2x cubed is negative 2x cubed. Negative 1 times x squared is positive x squared. I'm going to sneak that in there because I don't have a like term. Negative 1 times 1 is negative 1. Over the square, what's below? Nothing happens to that. X squared minus x plus minus 2 squared. Combine like terms all together. Distribute a minus sign through. Let me just go ahead and combine like terms here. So 2x to the 5th plus x to the 4th minus 4x cubed plus x squared plus 2x minus 1. So this minus sign is going to minus all this stuff. So again, when you get this product here, get it down to a simple polynomial that's being subtracted minus each thing is what's going on here. Okay? And then I can combine that with this at the same time, so I think we can all handle that. So let me just do that real quick. F prime of x. Let's focus on the 5th power stuff first. 4x to the 5th power is being subtracted by 2x to the 5th power. That makes 2x to the 5th. 2x to the 4th being subtracted by x to the 4th makes positive 1x to the 4th. Negative 16x cubed being added by 4x cubed is going to be negative 12x cubed. Negative 10x squared is being subtracted by x squared, makes negative 11x squared. Positive 4x is being subtracted by 2x, so they're going to be plus 2x. And then minus minus 1 is plus 1. All over x squared minus x minus 2, the quantity squared. That, do it on a scratch sheet paper. Keep it away from all your work. You have this nice, pretty answer right here on your paper. It will save you. Oh, dang it. This thing's harder. All right. Really. All right, f prime of x is that. We're trying to find critical numbers. Critical numbers occur when the top equals 0. That would be the places where the function equals 0. Where the bottom equals 0, that would be the undefines, and at endpoints which there aren't any. Okay, so basically you get to this point, you have critical numbers happen when the top equals 0, they happen when the bottom equals 0. When will the bottom equal 0? X equals what? 2 and negative 1. Okay? It's the same bottom, but it's squared, so the same zeros occur, right? All right. And again, these two things are going to be critical numbers all the way through the problem. They're not going to disappear. So I know x equals 2 and negative 1 are critical numbers. All those critical numbers are doing for me is they're creating a spot where the sign can change for this. All right, so keep that in mind. As far as the top equaling 0, I have no idea when a 5th power function is going to equal 0. So what I'm going to do is I'm going to use my calculator to find that out. So go over here, type in the top, so 2x to the 5th plus x to the 4th minus 12x cubed minus 11x squared plus 2x plus 1. I'm going to hit zoom 6, so it's the negative 10 to 10. That's usually where everything happens. We're looking for where it crosses the x-axis. It's like it crosses 4 times, so there's 4 critical numbers happening there. Oh, 5 times, good grief. 5 critical numbers, this is going to be awesome. All right, so 5 times it crosses the x-axis, so I want to find out each of those numbers. Let's see, looks like between negative 3 and positive 3, so if I zoom in a little closer, so negative 3 to 3, let's go from negative 5 to 5, because we don't care about anything that's 0. Try it again, see what happens. So, negative 2 looks like 1, a little bit left of negative 1, a little bit left of 0, right of 0, and about 2.5 maybe, I don't know. So we're just going to calc 0 on each one of these. So calc 0, 2. I'm going to guess negative 2.5 left, negative 1.5 right, guess negative 2, and we see that it is negative 2.03. Alright, the next one. Okay, second calc 0. Looks like about negative 1.1, so left bound negative 1.5, right bound negative 0.5, guess negative 1, and negative 1.14. Next one. Second calc 0. Looks like about negative 0.3, so left negative 0.5, right 0, guess negative 0.3, negative 0.25. Next one, second calc 0. Looks like about 0.3, so left bound 0, right bound 0.5, guess 0.3 is 0.34. And our final one looks about 2.5, calc 0, left bound 2, right bound 3, guess 2.5, and we get 2.5 to 80 or 80, so 5.8 or 2.58. All right. So 7 critical numbers altogether, which means there's going to be 8 intervals, negative infinity to each one, right? In numerical order. Just to make sure that I kind of glossed over this while I was doing it, when you do the calc 0, you kind of ballpark where it's at. Left bound too small, right bound too big, guess in the middle. All right, so as long as there's only one intersection between the left and right bound, you're going to find it. If I did, let's say, calc 0, and I said left bound negative 3, right bound positive 3, and then I guess, let's say 1, it's probably going to lead me to this one, but it could lead me to that one. All right. There's no guarantees. It did lead me to that one, but when you make that guess, it's going to do that. The only bad left bounds and right bounds will be off the chart. So we're going from negative 3 to 3, right? So if I said left bound negative 4, it's going to say error because it's off the screen. So you got to pick left bounds and right bounds that are on the screen. So that's one thing that might happen that you're not expecting. All right. So if I do all my intervals here, that's the smallest number, then this, then that, then this, that, and this, right? So, let's start over here. Negative infinity to negative 2.03, negative 2.03 to negative 1.14, negative 1.14 to negative 1, negative 1 to 0.25, 0.25 to 0.34, 0.34 to 2, 2 to 2.58, didn't start over far enough for that, and then 2.58 to infinity. And what I want to do is evaluate the sign for each of those, right? Look at the bottom, x squared minus x minus 2 squared, right? What sign's the bottom going to be every time?
Positive.
Positive, right? X squared minus x minus 2 squared is always positive, except when it equals 0. It's not going to equal 0 because we've already picked out where that happens, right? So the bottom's always positive. If we just figure out the top, we'll figure out the sign, right? And the top is graphed right here. Maybe there's the top graphed, right? So it's negative, positive, negative, positive, negative, positive, right? That's only 5 intervals though, right? We have our x equals negative, was it negative 1?
Negative 1 and 2.
And positive 2. So at negative 1 it doesn't switch signs, and at 2 it doesn't switch signs either, right? So if you can look at the picture and figure that out, that's perfectly fine. If you aren't as comfortable with that, then we can always go back here. I just need to get the bottom involved. If I put an insert parentheses, and I put an insert parentheses, there's the entire top divided by the bottom, x squared minus x minus 2, the quantity squared. I can go to my table then and pick numbers on the interval. Okay, so, hold on a second, table set, ask. Alright, so I would pick negative 3, negative 2 point, well let's go negative 1.7, maybe negative 1.07, let's go with 0, and let's go with 0.3, 1 point, 1's fine, looking for stuff that's not fine, 2 to 2.58, let's go with 2.3, and let's go with 3 here. Right. Nothing magic about the numbers, just numbers within the interval. I didn't want to pick negative 2, I suppose I could have picked negative 2, but I don't know. Just, I was trying to stay away from things that make the bottom equal 0. So negative 3, negative 1.7, negative 1.07, 0, 0.3, 1, 2.3, and 3. We get our outcomes, right? Negative, positive, negative, positive, positive, negative, negative, positive. Negative, positive, negative. Positive, positive. Negative, negative, positive. Alright, the only places that maximums, minimums aren't going to be allowed to happen would be at negative 1 and positive 2, right? So notice negative 1, if notice it goes from negative to positive there, right? But that's not a minimum, that's an asymptote. Okay, usually you see a negative go to a positive, it's going to be a minimum. And here when you go from a 2, it went from negative to negative, didn't change. It seems kind of weird.
Is it
Did I-
negative 0.25?
That's what I have.
I have negative 0.25.
Negative 0.25 on 0?
Instead of instead of,
No, on your thing, on your intervals.
instead of 0.5 I have negative 0.25.
Negative point. Oh, that's negative 0.25?
Yeah.
That helps. Okay.
That's why I was really confused.
Negative 0.25. Sorry about that. So that should be negative 0.25. So this should be a 0 here, which end up being positive. And let's go to negative 0.3, which will probably be a negative. Yep, good. All right, thank you for fixing that. So, and it's good that that happened only because if the negative to positive happened at an asymptote, it still doesn't make a minimum happen. But it stays negative, negative, so it's decreasing, decreasing. That's fine. That's allowed to happen. So, negative switches to positive, so it decreases, increases, decreases, decreases, increases, decreases, decreases, and increases. Okay, decrease to increase, not at an asymptote minimum. Increase to decrease, not at an asymptote maximum. Decrease to decrease, decrease to increase, not at an asymptote minimum. Increase to decrease, not at an asymptote maximum. Asymptote doesn't matter. Decrease to increase, not at an asymptote minimum. It's just like that. We got a whole bunch of points. Okay, and again, we still have our asymptotes, so that allows us to pick some points also. So we're getting a lot of information out of this one with the calculus. All right. Moving on to the second derivative. I almost don't want to. This problem's kind of hurting my feelings a little bit. It's getting uglier as we go, but we'll go ahead and take it on. I'm going to go a new page though, and let me go side to side. If I do the second derivative of f double prime of x, let me just take this real quick. So there's my f prime of x. If I go f double prime of x, do low d high minus high d low over the square of what's below. Low d high is going to be x squared minus x minus 2 squared. D high is of course going to be 10x to the fourth plus 4x cubed minus 36x squared minus 22x plus 2. Minus high d low is going to be 2x to the fifth plus x to the fourth minus 12x cubed minus 11x squared plus 2x plus 1 times 2 times x squared minus x minus 2 to the first times 2x minus 1 over the square of what's below, which is x squared minus x minus 2 to the fourth power. When I did high d low, notice I did the chain rule to differentiate the bottom. And I've told you about these rational functions that you should expect some stuff to happen. This power always gets doubled when we do the square of what's below, but it should only go up by 1. So the fact that it went up by more than 1 means that we got some cancellation possibilities before we start simplifying. If you do this, you're going to make your job so much easier and it's worth doing. So what I want you to notice here is we have 3 objects. Object 1 is this product, object 2 is this product, object 3 is that. X squared minus x minus 2 to a power, x squared minus x minus 2 to a power, x squared minus x minus 2 to a power. That is not a coincidence. That happens on rational functions almost all the time. I think every time. I'm going to go ahead and say every time it happens. Even if it doesn't happen once, you're still looking for every time, so it's worth me saying it every time it happens. All right. So I can reduce by this, the lowest power, so that goes away completely. This decreases by 1, this decreases by 1. And again, it's just polynomial multiplication. It's not very friendly, polynomial multiplication, but that's all it is. This is right here is 4x minus 2, right? So 4x minus 2 times that, x squared minus x minus 2 times that, you're going to multiply it all out. We know how to do this, right?
I'm going to cheat.
Just to save us time, we're going to get the bell ring on us here shortly. There we go. Parentheses, x to the second minus x minus 2 times 10x to the fourth plus 4x cubed minus 36x squared minus 22x plus 2 minus parentheses 2x to the fifth plus x to the fourth minus 12x cubed minus 11x squared plus 2x plus 1 in parentheses times 4x minus 2 in parentheses equals. All right. The program I used was Wolfram Alpha, 99-cent download. Very powerful. More powerful than any calculator I've ever used in my entire life. It costs 99 cents. If you already have the iPad. The iPad cost, of course, more than 99 cents, but the app itself, I think, was 99 cents. It might have been $1.99. Still well worth it. Anyway, that's the product of all the stuff on top, all added together. So I just type in that times that equals, and it spits out the answer. And what I'm looking at here now is, this is my second derivative. I want to find my critical numbers of my second derivative. So once again, the top equals 0, the bottom equals 0, gets my critical numbers, right? So if I type in the top, y equals 2x to the 6th, what was the next number? Minus 6x to the 5th, plus the minus 50x to the 4th, plus 46x cubed, plus 66x squared, plus 42x minus 2. Alright, again, zoom 6. I sure hope this doesn't cross 6 times. Cross my fingers. Maybe it only crosses like a couple times, that'd be awesome. There's 1. There's 2. 3. 4.
Still going.
Stop. Don't do any more. Don't do any more.
The little thing went on recording.
Did, okay, good, alright. So we got 4 critical numbers there. I guess it went down, then up, then down, then up. I don't know. I thought it went up to begin with, but up. Or maybe it went up, I don't know. Must have gone up, I don't know. So, if I look at my critical numbers here, zoom, let's see, calculate 0. Looks like around -4, right? So, -5 too small, -3 too big, guess -4. And we get -4.09. If I guess the second one, calc 0, looks like around 0, so -1 too small, +1 too big, guess 0, and it's going to be 0.04. And the next one looks to be close to 2, so second calc 0, too small 1, too big 3, guess 2, we get 1.77. And the final one looks to be around 1, 2, 3, 4, 5, 6 point something. So calculate the 0, too small 6, too big 7, guess 6.2. We get 6.26. And of course we have critical numbers of +2 and -1, because that makes the bottom equal 0 again. Just higher power, but it's still the same zeros. Set up your intervals, find your concavity, inflection points. I'm going to leave this to you guys to finish. Every x we got is going to be an x you want to pick to get points. You're going to want to plot your asymptotes, vertical lines dashed. And again, if you get enough information from the points you graph to get the graph, great. If not, pick some more values of x to get some more points. Expect the increasing and decreasing concavity, inflection points, maximums, minimums to be where they should be, and be able to finish it up like that.